You should have at least done it in Year 10 physics. Displacement, distance, velocity, speed, all of these things. Anyone want to help me out with a demonstration?
Wait, maybe.
So this is Caleb.
Hi, Caleb.
This is his start position. Right, can you go around the room and come back, please? Go. So let's discuss what happened to Caleb. His displacement was 0. What about his distance? 20-ish meters. So displacement is about your distance with a direction. Okay, so he displaced 0. He got back to his start position. But his distance travelled was the total distance he went, okay, which was approximately the classroom circumference. Okay, that's distance displacement. What about his velocity? His speed?
Easily. 7.
Let's say 5 kilometers per hour. So, going around the room, his speed most of the time was 5 kilometers per hour. Okay? What about his average velocity? If he came back to his original position, so if his original position is the same as his end position, remember we do average, it's the 2 points divided by 2, yeah? So if he's ending where he started, isn't his velocity average 0? What's it called? One-dimensional displacement. So we can just make displacement x. We can find the velocity by finding the derivative of the displacement. So the average rate of change of displacement of the displacement over time is the velocity. Does this sound familiar? We have done this already. Yeah? And then you could also write the acceleration is what in terms of x? What notation could we put for acceleration? If velocity is x dot, acceleration would be x double dot. Or we could also write it, do you remember this notation? F dash t. Two dashes for x. So these different types of notation we have discussed in the past because of different scientists or mathematicians, I should say. Okay, so here's a bit of a summary of the definitions. I'm not going to really go over them because I'm hoping you've remembered them from grade 10 and 11 science, okay? The thing I want to emphasize is the difference between, remember we talked about average versus instantaneous, yeah? So average, I said it already, you're finding what? By doing what? You have 2 points and you divide them by 2. Add them together, divide them by 2. Instantaneous, you need to do the derivative, yeah, to find the instantaneous point. Or you can use the tangent. Okay, so for example, I have a displacement of, 3t squared plus 4t what does the velocity become? So find the derivative, bring the number out the front, minus the power, and you get that velocity, yeah? So you could find the average velocity, say the starting point, and I don't know, after 4 seconds, say, you would put them into there, divide by 2, that's your average velocity. Does that make sense? So average would be 4, and then, so this is the, at t equals 0, I've subbed that into this equation, and this is for t equals 4, put that into that equation, and then you get your average. So that's the average velocity from the starting point, t equals 0, to the time 4 seconds. So the average across that time length was 16 meters per second. So I used the derivative to find that from the displacement formula. Okay? All right, we could also find the acceleration from that. So what would be the acceleration for this instant? I don't know, a particle or a ball or something. What would be the acceleration? Yep, so you just find the derivative of the velocity, which is just 6, a constant. And don't forget the units for acceleration, meters per second squared. I just made it up. So this, I just wanted to find the average velocity over the first 4 seconds. So if that was a question,